All right, welcome to the CICON Advanced webinar. Today we'll cover kind of theme options as well as some extra tooltips and special programs. Um, there is not a presentation for this one, as this one is more demonstrative than actually presentable. So I will be jumping right into it. The first thing that I want to mention is we are using a normal scan program for future examples. So I'm just going to do that by creating a new program here. And I am using a PLCS CM3, double check it, CM3 SP16 MDTF as the PLC. That's not really important. However, this PLC does support positioning and high-speed counting, which I will be demonstrating with for the special programs as well as the special modules. So I'll jump in with kind of themes and tools. So if we go to tool and options, this menu here will pop up. This is how you can configure CICON and everything within CICON. So in the general tab, we have all these startup options. So if you would like to open the last project or open the last programs in your project, well, opening a project from file, recent, or any of that, you can do so by selecting these. You can hide the variable editor table by checking this. So if you open CICON, the variable editor, which is just this little side pane here, will not open by selecting this little checkbox. You can also hide all of the update news as well as upgrade notices by checking this box. The splash logo, which looks just like this right here, will pop up if this is unchecked. So if you check this, that will no longer pop up, as well as some other additional settings. Over here on the UI, you can hide the online status bar, pop-up message dialog to disable, which is that little checkbox down here that says when a device is unplugged or plugged in. So this little box that popped up. And when I plug that PLC back in, it should pop back up. However, I like to leave this unchecked so I can see that my PLC has been recognized by the system. Taskbar status, this little option down here that says ready, as well as module info marked by module name. Some general settings, compile before download. There's an autosave setting for the projects. You can change the intervals in minutes as such, as well as creating a backup size. So if you want to back up your program while auto-saving, you can do so here, as well as comparing after downloading a project, checking for variable usage, etc., as well as download settings. So you can choose not to download variables, which are just over here on the side pane for variable editor. So you can choose not to download those alongside your program. So if you were to download the program from the PLC to a different separate computer, they will not show up in the variable editor window over here. Function block information, um, and PID program set value offset warning. So those are just some of the general settings, as well as I want to mention the location of your program that you've made. You can save that or change that up here. The LD editor is what this looks like back here for the scan program. So some of these settings I personally like, such as enabling the Modbus tooltip, but I'll go over that in a moment. So you can enable all of these or disable all of these, such as a duplicate coil warning. So if you were to include two separate coils, so if I do F, if I do M10.A and then create another coil of the same, and I compile and download, I will get an error. So if I just do this 10, another one with F10, compile download. online edit, if I do one more, you can see that the duplicate coil message appears and it tells us what variable that is. So if we go back to online, or if we go to tool options and LD editor, we can disable that message. However, I like to leave it on because a good practice is not have any duplicate coils in one scan program. Empty rungs are deleted by default. If you select this, that will not occur. You can also use the old LD editor. However, I like this current version, so I leave that unchecked. Display device list, such as data registers, variable list, all of that. Over here under Modbus tooltip, this allows us to see the Modbus address for all of the data registers used in CICON. So if I create an X variable as well as a Y variable and delete this, then I create an M and a D register. I can download this. And if we hover over the data registers themselves, you can see the Modbus address for X 1.0, which is just bit 0 of the word X1. Y 1.0, same thing, the 0th bit or first bit of Y1. D100 or D10.0, since it is a coil, you can see that it is the Modbus address right there, as well as M register right here. So if we do some other coil, or not a coil, but if we switch these to D10, D100, sorry, I apologize. That will not work, but that is how the Modbus tooltip is useful for this example. So you do not need to do the mathematical conversion or any of the finagling of trying to get the correct Modbus value. So all you have to do is just enable the show Modbus tooltip here under LD editor and restart CICON. If you don't restart CICON, it will not show up. If we come over to the SFC editor, this is for the sequential function chart. All of these will appear if we are creating a new sequential function chart program. So go back to the options menu. We can enable simple dialog, the editor toolbar, which is this toolbar section right here that includes transition editing and step editing. These messages, we can disable them for the ladder diagram section, which it is over here on the right. The delete confirmation on the SFC instruction over here on the left, as well as the symbol characters and whatnot. For function blocks, we have the same kind of example. So we can display the data types for bits, words, double words, or floats for a scan program, hide or select a CPU type. When exporting a function block, unfold the user library tree when a project is initiated, so on and so forth. Over in the structured text program, we have some options such as registering global variables and setting them to retain. Local variable default data type is set to an integer, or we can use any of these examples here. Same thing for a global variable, which is set to a real by default, an array, or a struct. These default values can be set. I'm going to go back to the LD editor and show this example down here. So we have font. We can select a default font as well as a default size, and we can actually change the colors. So I want to exit out of this and go back to the scan program and show you. And I'm going to create another example where I'm using a basic add instruction. So here in the color settings, we can see basic editing mode is just a simple white background. That is the color back here. In run edit mode, it will show this kind of lightish green color. Rung edit mode is this lightish blue color. So we can see that this new rung has been added and needs to be saved. So we can actually select it to be this light blue color. We can change that if we need to. In monitoring mode, you can select a default color and the CPU stop mode. Variable names can be changed to a certain color. So I want to actually move this over here. And I'm going to download this back to the PLC. The next thing I'm going to do is give this a description. Head over to Tool, Options, and back in the LD editor while editing these settings for the colors. We can see that the variable name and comment are green. So if I change comment to red, hit OK, OK, they now display as red rather than green. So I'm going to change that back to that green, however, because I'm very used to that color. But constants, these numbers will display as black. So rather than D0 here, if we had a number such as 1, 200, 1000, any of those numbers, they will display to whatever color we set. And the device address is the same thing as the data register. So D1, D0, D2 all displays this color. The operation is the same thing as the instruction. So we can see that add is a slightly darker purple. I can change that color back to black, hit OK, and we can see that it kind of changes back to black there. It's a little bit tough to see since the previous color was a dark purple. And the last thing is you can set different colors for timer and counter instructions, the send and receive instructions, and the from and to instructions, since those are a little more advanced and helpful for Modbus or timers or sending information to and from buffer memory. The SFC or sequential function chart editor contains the same type of editing. So you can change the editor background, the mouse cursor boundary line, dotted line, the step count, step number, transition number, modified area, instruction symbol, dummy step, ladder diagram protocol symbol, or the monitor mode symbol. Under the function block, the same thing can be set for the program background, the title, the EN, the ENO variable, the data type for bits, words, double words, and floats, the device or data register, descriptions, or the function block box color. And to exit out of these ones, since there's no X, I believe that will be fixed in the next version. You can just press escape. For structured text, we actually have a little bit more. So you can change, again, the font color, the font style to be bold, italic, bold and italic, or regular, as well as the font size. Plain text color, the plain text background color, text color and the text background color, which you can see is displayed over here. The breakpoint background color is also set here. We go to syntax, you can change the comment, local variable, global variable, and constant colors, as well as the data type, reserved words, and instruction colors. Under hotkey, this will allow you to designate a hotkey to enable any of these actions, which are up here in the menu bar. So if you would like to open a new project, you can do so by assigning a hotkey like that. All you have to do is just press the hotkey. So if I press Alt and H at the same time, anytime I press Alt H, it will create a new project. If I would like to unassign it, all I have to do is release the Alt key or just press unassign. You can set default presets, so any CIMON or Omron or any of these other options have been created by CICON. And lastly, we have themes. As you can see, my theme of CICON is a little bit different than the default. And I've done that by going to the color filters and kind of shifting these colors around. There's also default options. So if we would like to switch to any of the options such as Office or Windows 10, that is available. However, I'm going to stick with my default. That looks like this. If I don't hit colorize, it will look red, saturated, I guess. But I will hit custom, and we kind of have this darker feel to it. So those are some of the options that you can do within CICON to make it a little more useful and user-friendly. The next thing that I want to cover is actually enabling the view. So if we go back to the LD editor, we can select the, I gotta look for this one. Give me one moment. Sorry about that. The use zoom function over here, it is checked off by default. However, if we check it and hit OK and restart CICON, over here on the left side, the zoom in and out functions are enabled. However, it doesn't scale resolution wise, but it is a lot easier to read by changing these values. You can also go over to view and change the zoom to be 200, 150, 100, or zoom out to 75% or 50% by default. One more thing I'd like to mention is by default, this option here in CICON is unselected or unchecked, so the allow dots for device input, which means by default, if you were to type X10 rather than X1.0, it will show as X10. However, enabling that dot will allow us to view everything on a bit level. So if I was to add the M10A, it will now give us the 10th bit or the hex value A bit and display it for the word M10 rather than combining it all in one. That option also needs to be reset with CICON, so just close it and reopen it. Okay, the next option that I want to go through is high-speed counting. So if we go to the special configuration by creating a new project, we can select the high-speed counter for the PLCS and hit OK. This will allow us to do a high-speed counting program, which I will show as such. So We can select the starting address with the D registers, M's, L's, or K's. So I'm going to start with D0 and only use channel 1. And I'm going to enable count. If this is unselected, the high-speed counter will not work. Selecting the enable comparison output for Y will allow an enable a comparison output to be enabled. Latch count means that it will retain memory if the PLCS loses power. So it will retain the current value in a non-volatile memory. And the enable external preset will enable an external preset for or preset for your high-speed counter if that is something that is needed. So we can view the status flags down here, such as the enable count, the comparison output, the carry bits and borrow bits, any error codes that are needed as well. So we can hit save. And I will download this program to the PLC. So monitoring will allow us to look at the processed value here. So no editing is allowed, as it mentions here. But we can see that we are using a linear counter with a two-phase two multiplication. The current count is currently less than the compared value, as well as the internal preset, external ring counter. But this ring counter doesn't matter as we are linear counting and all of these other options. However, if we go over to help, select CM3 and go to high speed counter. We can select parameters and we can see how all of the high speed counter is processing our values. So it uses 26 total registers for each channel. So if you were to use both channels, it would use up to 52 registers. The important value that we want for the high speed counter is 26. So if we look at the current value, down here, is actually 21. Sorry. So the 21 and 22, it will read the current value in a double word. So we can count somewhere between negative 2 billion to positive 2 billion. So if we use register 21, we will get the lower end of the double word. And that is because I set the starting address to D0. So there is a 21 and 22 offset from that starting register. So if you were to start at D1, this value would be 22 and 23 respectively. So I can go back to the ladder logic and I will create some rungs. And then I'm going to run a greater than instruction. So I will set D22 and the value of D1000. And when that is true, Y10, Y1.A will turn on. So I'm going to change that value of D1000 to 100. You can see our current count is 0, but over here on my high-speed counter module, if I start changing the dial to be a different value, let me double check that D22 is the correct one. It is not. Sorry about that. I'll change this back to D21 for the lower word. We can see that our value is now 8,000. So if I turn the dial back, The negative 112 is less than 100, so y1.a turns off. But if we get it just above it, it'll turn on. So again, this is our current value in our high-speed counter right here. And again, that is found, this information in the help file is found by going to CM3, high-speed counter, and parameters, scrolling down to the current count value. The next part that I would like to demonstrate is positioning. So we will create a new program and create a positioning for PLC-S. And we will hit the output pulse type. I will change to be a high active. You can set it to low active or NA for not applicable or not available. However, if it is NA, none of this positioning information matters. So I will hit save and download this back to the PLC. However, I have made a mistake in doing so. So one information piece that I'd like to give is each special program has a starting data register. So we can see that up here, the start address for high-speed counting is where you would like it to be, reserved at D0 through D52 if you're using both, or D51 for both channels. Positioning uses more registers than that, so I actually want to begin at D100, and I will just do an online modify here. So rather than re-downloading, it will just change our starting register to D100. If I go back to the help file, CM3 positioning, and navigate to the operation data, we can see if we want to control our positioning information or any motor, we can do that via the ladder logic like this. So this only uses 19 words for operation data. And the important stuff is in the control flag with enabling and disabling an access, decelerating stop request, or an emergency stop, or forward or backward jogging. The F bit down here is important. So if you are to enable bit 2 at an offset of 0, so D100.2 in this case, it will trigger this to turn on. To clear it, all we have to do is target this bit, and I can show that in the ladder logic. So if we go back, create a one-shot, and then we target coil of D100.3 according to the position data. This will forward jog, and we can see that by going to the monitor section of this special program and then going back to the ladder logic and enabling. So we can see that our current speed is currently 100 pulses per second, and our pulse here is actually our positioning address. So if I stop it, our address is now at 1,715,509. That is our current address. If we would like to view that in the ladder logic itself, we can do that by getting the lower position or the lower word of bit 102. So I can display that. By doing a simple compare to D1000. So if I do D102 to D1000, turn on coil 1.e, we can see the position here. However, this is just the word representation, so I'll actually change this instruction to a D comparison. And now we get the full word and our position there. So that's kind of how we can use the ladder logic to read operation data for positioning, as well as kind of understanding how these tables in the help file actually work. Since again, this is more about CICON rather than positioning and high speed counting. This is a demonstration of how we can use the help file to read this information, as well as monitoring through both high speed counting and the positioning, as well as navigating back and forth between the the special programs. One last thing is we actually don't need the ladder logic for positioning. We can control it here by doing this. So we can actually see that we are going backwards at 10,000 pulses per second rather than going forward. If I hit an emergency here, we can see that this error reset pops up and D101.f, which is the same as D101.f, we can see an error occurs. If we hit that reset, it is the same thing as turning on D100.f to error reset. So that covers this section of CICON a little bit more advanced, kind of going through the help file and reading these tables, as well as some extra helpful tips for the ladder logic that we can see here by hovering over for Modbus addresses, as well as some theme designs and designer settings for CICON itself. The last thing that I would like to go over is the current help file is very dated and can use a touch up. So currently my project is to make an online version of the help file similar to our Canvas help file. So you can see here our Canvas help file has a Korean version, but the English version here is very well laid out. So if we go over here, we are trying to accomplish the same thing with CICON by displaying everything. So if we look at an addition example, if we go to the instructions, arithmetic addition, we can see that these tables are outdated as they don't include each data register. And the examples could use a little bit more, even though this is addition. We have broken it down and included a lot more information about what is allowable for each data register. If I display this in light mode, it will match. So you can see these examples as well as the demonstration and pictures that go with it. So we are currently working on that, and we hope to be done with it soon, as well as creating some sorry about this, some tutorials for common questions such as Modbus. So if we go to a special program,
Yes, sir.
and not special program, where is that? Communication program. We can go to Modbus TCP master and we can see that we have full demonstrations here. All these other examples are not yet finished since this help file is taking a while, but I do want to just note that this help file is in progress to hopefully replace or at least provide more information than this current help file. So that will conclude the webinar. I will stay. If there are any additional questions, I will be happy to answer. Thank you all for attending.